medians and altitudes. Last two we are doing. We've already done the perpendicular bisector and the angle bisector. We are working on these now. What was that? Okay. First one, medians. Okay. A median is a segment joining the blank to the blank blank. All right, let's get our picture, we'll get our drawing, and we'll figure out what is what. Okay, so let's draw our triangle over here. I'm going to call this A, B, C, triangle ABC. Everyone have that triangle down? Okay. It connects the median, I'm sorry, the midpoint. The median's what we're finding. It connects the midpoint. What does a midpoint do? It cuts a line in half. So it joins the midpoint to the opposite vertex. Okay, and there's three of them because there's three sides and three opposite vertices. Okay, so let's, again, we're not going to pull out the tools like I have in the past. We're just going to mimic it the best we can. So without a ruler, best you can, find the midpoint. For example, would you mark that over there as the midpoint? Does that look anywhere near the halfway marking? No. Make sure you guys are keeping phones put away, please. Okay, so best you can, find the midpoint. And I connect it to the opposite what? Vertex. And I have a marking there, and that is my, what is it called? The median. The median is made up by connecting the vertex to its opposite side right down the middle. Would I call this a perpendicular bisector? No. Did it bisect the segment? Yes, but is the line perpendicular? No, it's not perpendicular. It's connecting to the opposite vertex. All right. We've had names for where they all meet. This name is called the centroid. The centroid is the point of concurrency. The point of concurrency of the medians of a triangle. All right, so let's draw our triangle. And I'm going to call this again A, B, C. And we're going to draw a bunch of medians, the median for each side, and connect to find the point of concurrency. Point of concurrency means when three or more lines intersect at one point. Point of concurrency. Okay, so if we had our tools, we would first find the midpoint. So let's do the best we can. I'm going to say that's the midpoint right there. What angle am I going to connect that to? AC? I'm sorry, to angle C? Yes or no? Okay, when I connect that over to angle C, What can I say about these two segments here? They are equal. All right, turn your paper and do the same for BC. Do the best you can to find the middle of BC. And what angle am I going to connect this midpoint to? A, because that's the opposite angle. Are these angles perpendicular? No, they're not. Are these segments congruent? Yes. All right, now I'm going to flip it one more time and find the midpoint of AC and connect that to what? What angle? What is the opposite angle of side AC? B. All right, and we call that point of concurrency what? The centroid. I'm going to highlight that because you want to make sure you study that for the test. Okay, so that point of concurrency right there is called the centroid. Oh, what can I say about these two segments right here? They are congruent, they're equal. All right, so when you're looking here, again, this one doesn't have all the wording that the other one had, but when you look at this image right here, which one, A, B, C, or D, this is from your review, by the way, A, B, C, or D is made up of the medians. The median cuts the side in half and goes to the opposite vertex. Which one? C. Kids will say this, yes, it cuts it in half, but what kind of markings do we see here? Does anybody remember what this one's called? This is made up of the what? The perpendicular bisectors. This one's made up of the angle bisectors. We haven't done this one yet, so we'll do that one now. Questions on the medians or the centroid? Okay, what's the last one we're doing? Altitude. Okay, let's write that down. Altitudes. Okay, an altitude is a segment joining the vertex to the opposite side. All right, let's draw our triangle. Okay, I'm going to pick vertex C. It says an altitude is a segment joining the vertex to the opposite side. What side is opposite angle C? AB. Now, I just talked about in homework, when I'm connecting points to a segment and I'm looking for length or I'm connecting, do I just randomly draw lines? Remember when I said it in homework, what kind of lines do we draw? Lines that are what to the base? Perpendicular. All right, so you want to make a note that altitudes, an altitude is a segment joining the vertex to the opposite side. Make a note that it is perpendicular. So you're looking for perpendicular markings when you're doing these on the test. Okay. Questions on what an altitude is? Okay, last piece. What is the point of concurrency of all the altitudes? It is called the orthocenter. I know, that's what my other class said as well. Orthocenter. And the orthocenter is the what? The point of, what do we call it when they all meet up at one point? What was it? The point of concurrency of the altitudes of a triangle. The orthocenter is the point of concurrency of the altitudes of a triangle. So we're going to draw our picture. A, B, C. Okay, so I'm going to start with vertex C. What side is opposite vertex C? AB. And I want to draw it so that it's perpendicular to side AC. That there is my altitude. So when you're looking for altitudes on the test, you're looking for a line that's perpendicular to the base and goes to the opposite vertex. Okay, now I'm going to turn my triangle around. Now I'm sitting at vertex A, angle A. What side is opposite angle A? BC. And you want to draw a segment that doesn't cut the angle in half, it doesn't cut the side in half, but it is what to the opposite side? Perpendicular. So these are not cutting sides in half, they're not cutting angles in half. All right, and the last one. I'm at angle B. What side is opposite angle B? CA. So when I draw my line, again, I'm not cutting the angle in half, but I'm trying to make a line that is perpendicular to base AC. Okay, let's put it right side up. What do we call this point of concurrency right there? The orthocenter. Okay, so make sure you are studying. I'm going to put this image back up really quick, and I will put that back on. Right here. Orthocenter is made up of all the altitudes. Altitudes are perpendicular to the base and go to the opposite vertex. These are the only two places I see perpendicular markings. Is it A or is it D that goes to the opposite vertex? D. So these are your, what is it called? This is your orthocenter. Knowing how to read these are made up of what? What are these segments called? Perpendicular bisectors. Look at these, cut all the angles in half. What are these segments called? Angle bisectors. One of these is the medians. One of these are the altitudes. Medians cut sides in half and go to the opposite vertex. Which one is that? And this one is called the what? Not the special name, but it's made up of the what? Altitudes, perpendicular to the base, opposite vertex. Know how to read this, guys. That is on the test. All right, questions? No? All right, that's it for this lesson.